Assalamu alaikum wa rahmatullahi wa barakatuh. Dear student of second secondary, we are going to start syllabus of second term. We are going to have two chapters. Chapter 3, bonds and forms of molecules, and chapter 4, representative elements of the modern periodic table. We are starting today the first chapter, chapter 3, as we have in our book, and we are going to illustrate the first lesson from it. We are going to talk about ionic compounds in this chapter and the shape or octet rule. Second, we have different kinds of bonds. We starting with ionic bond, covalent bond, coordinate bond, and we will end at the last by the different physical bonds till the end of our chapter. Okay, we will start today by remembering the first rules for this chapter. Okay, we have the title of our chapter, bonds and forms of molecules. Okay, let's start. Okay, at first we are going to remember some standard. Okay, we have going to start with some standards that we are taking before. We will have standards to know what happened to the atom to form a molecule. Okay, if the atom is similar to the other atom, we are going to form a molecule of what? Of element, as they are similar. We have taken this fact in the first term and we are studying them a lot of years before. Okay, second one, if we are going to make combine of atom with a different atom, we are going to form what? A molecule of compound. So molecule different according to the kind of atoms that join together. At first, if we make exchanging to the electrons, okay, one lose and the other gain, so we have a kind of bond. We can say this kind is ionic bond. We study it in first prep as by simple methods. Okay, we are going to illustrate it in details now. Okay, so students know atoms combine to form molecules by sharing. To form a kind of bond, sharing means each atom share or participate with the same number of electrons. If the atom share with one electron, the other one share with the other electron, so we called it single covalent bond. If the atom share with two and the other atom share with two electrons, so the bond will be double or dicovalent bond. The third one, if the atom share with three electrons and the other atom share with the same three electrons, so we have triple covalent bond. This is the first one. And second one, we have metallic bond. Okay, so we will discuss metallic bond in this chapter also, or by changing of electrons, that we mean, or that we are going to study to form what? Ionic bond. Okay, we are going to form ionic bond. Okay, also we are going to know how salt crystals forms. As we study in the first secondary, we have crystal ice or crystallats of what? Of sodium salt, sodium chloride salt. Sodium chloride salt, okay, what happened to form a geometrical shape called crystallats. Okay, we want to know what happened to forming it. We make a repetition for positive ions and negative ion. So we have positive ion till it or after it negative ion, and also repeat after it positive and after it negative, till forming electrostatic structure or make attraction force between the positive and negative ion, forming the shape of crystal of the ionic compound. Okay, let's continue our studying today. We want to remember at first, okay, some facts that we are studying before. Okay, we have the shape here. We wanted to remember some facts that we have taken. One of them in the first term, that the oxidation number. Okay, what we will use with the word oxidation number. Here if we have example like what? Like sodium phosphate. Okay, what we want to know from this compound, we have here, we want to determine the cation and the anion of the given formula. Okay, at first, if we have a salt, any salt starts with the positive radical or positive ion followed by the negative ion. Okay, what is the meaning or the new word that we have taken? Instead of positive ion, we take the word cation. So we have any metal. Oh, it is a metal. Yes, it is a metal that lose electron or 2 or 3 during the chemical reaction here. So it will form an ion, a positive ion. We called it cation. The other one here, we have second part of the salt, we have a negative ion, gain 1 or 2 or 3. Okay, I will complete the sentence after a time to take the word that we want to get in our lesson today. Okay, anion here means that we take more than one or more than electrons in the formula here. So the first part or the part that takes the positive ion or the positive radical as we say, or oxidation number, lose electrons, that take the word cation of the first part of the salt. The second part of it, the gain electrons, one or more, we say it is an anion. So if we have electrons here, cation have only one oxidation number here. Okay, how we will write at first? Yes or no? Yes or no? Does the cation have only one oxidation number? I don't know. Why? There is more than one metal that take more than oxidation number. We will studying it completely, or we will in the next year we will take more than element, take that like the transition elements that take more than one oxidation state in as a metal. Okay, so if we have a cation have only one oxidation number, so we will write the name of the cation, then write the name of the anion without any addition to it. Okay, so here we have, I think it's very important you study it in the previous year, but I think in the first secondary you not concentrated in some points that you think it's not very important, but now I think you have to. There is no choice. You are in the second or secondary. It's very heavy year that take a lot of information that you will use in the third secondary. You have to concentrate on this point as you are in scientific section, not any other part. Okay, let's continue. If we take sodium phosphate, so the oxidation number here of sodium positive 1 only and phosphate negative 3, so the formula here will be Na3PO4. Okay, I think it's easy and simple. Another example here, if we take the other example, I think it will be different. Okay, there is no choice to be different. We have iron oxide. Do you think that we will read it as iron oxide? Okay, we have here iron as a metal. We have two oxidation state that we have taken before in the first prep. We have iron 2 and iron 3. Iron 2 we called it ferrous, and iron 3 we called it ferric. So we can't mention, or we can't say that we have here iron without any words oxide. So what happened to it? Iron have several oxidation number, but its chemical formula it will be Fe2O3. What happened to it to write as a cation and anion? Okay, there is no problem here in the formula, but we can't read it. We have to write the name of the cation followed by the Roman number or numeral to represent the charge. We have to represent what? The charge. Next, write to the name of the what of the element or the anion. So here, if we have to write the name of this compound, Fe2O3, its formula, but we can write it iron 3 oxide. I think it's very important point that all of you have a missing in it. All of you missing this point. I think you have to concentrate what you have missed in the first. Secondly, please concentrate on what you want. Every session I will collect some important missing parts from the previous years and we will discuss them together. Let's continue our lesson today. Okay, we will study what? We will study the bonds. Okay, we have here what is the meaning of bonds as all. As all bonds means force that holds the groups of atoms together. Okay, so if I want to get a force from one and another force from the other, so we can say we are forming ionic. We are ionic, or make them as function as ionic. Okay, so if we will study the bond, we must know it is a kind of force that bend or make the function of holding all the molecules together to form the matter around us. Okay, so we have the first one, ionic bond. Ionic bond depend on the transfer of electrons. Second one, here we have covalent bond formed by sharing of electrons. Okay, let's continue. What happened to form the first kind of our bond together? We are going to discuss very important one in our life or around us everywhere, the ionic compounds. Why? Because it is present in nature around us, like the salty water. Salty water, it's around us everywhere, in the oceans, in the seas we have salty water, and about 70%, 73% will be salty water. So ionic compounds present everywhere around us, as most of the earth will in the ionic form or ionic bond. Okay, what happened to form this kind of compound? We will form the stability for making this kind of compound, or we make octet rule. We called it octet. Octet means 8 in the Latin language. We have the name octet. Okay, so we have ionic compounds form so that each atom make what? If we take one of them, one will lose and the other will gain. So by gaining and losing of electrons, we have the octet shape or octet of electrons in its highest occupied energy level. Why? To make the compound stable or to form the stability state. Okay, metals, as we say, that have one or two or three electrons in the outermost energy levels, so it will lose the electrons to form positively charged cations. But non-metals gains electrons to form negatively charged anions. Okay, let's continue. If we are taking the ionic bonding, we are going to take the shape of this bond. What happened here? We have the sodium atom lose one electron here, and chlorine atom when gain the electron, it will changes in the name and shape. Okay, so we called it chloride ion. We have a sodium atom and chloride ion, so one of them lose and decrease in size, as we have the atomic radius will decrease in the metal as we take in the first term. So we have sodium cation here and chloride anion that formed here. We have Na plus and Cl negative, so we form here what we called ionic bond or bonding. Okay, let's continue. Okay, what happened to form ionic bond? Or we will take example for ionic bond. We have sodium chloride. It is the simplest example that we have taken before, and we are going to illustrate it as all. Sodium has one electron. We called it valence electron. Why? When lose it, it will be monovalent electron. So this electron depending or measuring the valency for the metal atom of sodium. Okay, we have here sodium, its electronic configuration 1s2, 2s2, 2b6 and 3s1. Here we have the one valence electron, and the other one we have chlorine has 7 valence electron. Chlorine has 7 valence electron that need only one electron to complete its valence shell or valence orbital. Okay, so here we have chlorine, its electronic configuration or electronic structure 1s2, 2s2, 2b6, 3s2 and 3b5. Okay, we have here the orbital of 3 or the third orbital that contain of 3s2 and 3b5. What happened here? Sodium will lose an electron transfer, gives each of them an octet state. Okay, so if you want to reach the octet state, we have to one of them lose and the other will gain. Okay, the formation of sodium chloride here, transfer of ion from each of atom, one lose and the other gain, each with an octet state. If we have sodium here, after losing we have 1s2, 2s2 and 2b6, and we write above its atom after losing we have it a cation Na plus, and the other one chlorine here, after it we have, or we will write Cl negative 1s2, 2s2, 2b6, 3s2 and 3b6. It's the outer one here. Okay, so each one ended with 6 electrons in the b orbital. Okay, okay, b sublevel filled with 6 orbital, 2 in each orbital. As we say, b have 3 orbitals, bx, by, and bz, each one filled with 2 electrons, opposite in direction with rotation. So we have complete energy or complete filled with electrons. So we have here the octet state for the each element here by losing or by gaining. So the ions here means that we reach to the octet state of the element or the atom or forming the ion. So we have here the octet state by losing or after gaining and losing of electrons. Positive ion and the negative ion in this table we will discuss sodium Na plus and Cl negative. The net charge of the compound must be equal 0. By losing and gaining, the net charge of compound will be equal 0. So if we have a compound here, we have ionic compounds like magnesium Mg plus 2 and Cl negative, and its chemical formula MgCl2. Okay, so we will write magnesium chloride loses 2 electrons and each chlorine gain 1 electron, so the 2 chlorine atoms have 2 electrons. Second one, here we have sodium oxide. Sodium oxide, each sodium loses 1 electron, and we write it Na2O, Na plus and O negative 2. So we will write its chemical formula Na2O. Each sodium loses 1 electron and the oxygen gain 2 electrons. Another example, here we have Al2S3 or aluminium. What? Aluminium sulfide. Aluminium sulfide, each aluminium loses 2 electrons. Each aluminium loses 3 electrons here to form 6 electrons, and each sulfur gain 2 electrons, so the total will be 6 as whole. The total will be 6 total in each atom, 3 times 2 and 2 times 3, so the total will be 6 electrons loses and gain. The monoatomic ions, we have non-metals or ions. We have the name fluorine. After that we have its atomic, or by by gaining 1 electron, so it will name will be changed fluoride. Okay, I will leave these tables for you in the video. You will see them, okay, as all, and I will make papers for you to study them hard. Okay, let's continue. We have sodium chloride crystal here. So we have ionic compounds form solid crystal at ordinary temperature. Okay, so ionic bond organize a characterized crystal, lots of alternative positive and negative ions, all salt form what? Ionic compound and form crystals. So it will form crystal shape, or we can say it crystallates. So any ionic compound like sodium chloride forming a crystallates. What are the properties of ionic compounds? Okay, we have a crystalline solid, so its structure will be all of them in the solid state or crystalline solid. And also the main point is that we are going to study that they have high melting point, generally high comparing to any other kind of compounds. Boiling point here also, as melting high, boiling will be high point. And electrical conductivity, it will be excellent conductor, molten and aqueous. If we make a molten by increasing temperature, or if we dissolving it in a solvent, so it will form aqueous solution, and like dissolving salt in water, forming salty solution, so it will be a high conductor or excellent conductors. When soluble in water, generally all salts or all ionic compounds are soluble as all in water, as water is a good polar solvent compound for each one in the ionic compound. Also, we have here common polyatomic ions. We will mention it. Some of them we have taken before, like ammonium NH4 plus. We have all of them have the radical or atomic radical negative, except one, ammonium, take the radical positive, NH positive. All of them take the radical negative. We have nitrite, NO2 negative, nitrate, NO3 negative, hydroxide, OH negative, cyanide, Cn negative, MnO4 permanganate, HCO3 hydrogen carbonate, or some of them say bicarbonate, ClO hypochlorite, ClO2 chloride, ClO3 chlorate, ClO4 perchlorate, BrO3 bromate, and IO3 iodate. The other side here we have IO4 negative per iodate, C2H3O2 acetate, okay, as it belongs to the organic compounds, H2BO4 dihydrogen phosphate, CO3 negative 2 carbonate, SO3 negative 2 sulfite, SO2, SO3 negative 2 sulfite, CO3 negative 2 carbonate, SO3 negative 2 sulfite, SO4 negative 2 sulfate, okay, by adding one oxygen, S2O3 thiosulfate, O2 peroxide, O2 negative 2 peroxide, CrO4 negative 2 chromate, Cr2O7 negative 2 dichromate, HbO4 hydrogen phosphate, or we can say some of chemists say bisulfate, BO4 negative 3 phosphate, and the last one here we have AsO4 negative 3 arsenate. I think I collect all the polyatomic ions for you, and you have to study them and remember the valency or atomic radical for each group. Okay, let's continue our lesson today. We will make a checkpoint for our questions. We will start. I give you a sample questions to remember that we are studying today. We will start with question number 1. Says that cations form when atoms electrons. Okay, we will cations lose or gain when atoms form an electrons. Okay, atoms electrons lose or gain, so cations gain, lose, or charge, or delocalize, or making a change in its place without going to a different or a definite place. We have here cations form what? Forming ion. That ion, when the atom lose or gain electrons, when the atom lose electrons. So the right answer will be the atom lose an electron, okay, or more. So electrons lose or gain. Question number 2. I have a checkpoint. What is the repeating pattern of atoms in an ionic solid called? I think it's very important question. We have the new questions for this point when studying it. The first name we have crystal lattice, ionic lattice, energy lattice, and ionic bonding. So I think you understand now our lesson. So the right answer will be crystal lattice. Okay, I think it's easy, and you have to mention all, or you study the lesson after you hear the video. Okay, question number 3. We have here electrons in an atom's outermost energy level are referred to as what? Okay, ions or cations or valence electrons or noble gas electrons. Okay, I think it's very also important question. I gave you the newest question for this lesson, especially this lesson. As we start it, you think it's easy like that we have studied before in first prep, but we mentioned a new words today, that we have octet rule or octet state and valence electrons. We have electron dot structure. Okay, don't forget these words that we are going to illustrate as all. The right answer will be valence electrons. The right answer will be valence electrons. Okay, we are going to question number 4. What is the oxidation state of copper in copper 2 Cl2? We have here the name. In the Latin name we write numeral or name or Latin numeral. In case of we have more than oxidation state for the elements, we have copper 1 and copper 2. Here we have here copper 2 forming a salt Cu2Cl2. Okay, what is the oxidation state of copper here? As it will lose 1 or 2 electrons, we have here +1, +2, -2, and unable to determine. So the right answer will be here, as we have the Latin express the loses electron. So the right answer will be +2. Okay, this is the oxidation state of copper in our salt today. The last question here we have number 5. Which elements naturally occur with a full octet of valence electrons? Okay, we will start. This is the first one: alkali metal, alkali earth metal, halogens, and noble gases. Okay, we say that if we reaches to a full octet state or octet of valence electron, so we are in similar to or in stable state. Similar to what? Similar to noble gases. We are similar to noble gases. I think also it's old information, but we take it in a new way to express it. Okay, we have examples for ionic compounds. We have here, I collect some examples and uses for you, for information for you. We have sodium chloride, lithium iodide, potassium iodide, sodium fluoride. Some of these are important to our life and we use it in everywhere around us. Okay, we have the last slide here. We have, I need to say to you, we can summarize that we are going to illustrate in the next session, and we have to say it in the previous years together. We have the ionic compound formed due to creation of ionic bond, which is electrostatic attraction between the positive charge and the anion negative charge, cation positive charge and the anion negative charge, generally involving a metal and a non-metal. So if we are going to nomenclature or saying it, we say that charges written, because ions either positive or negative charge, name the cation first followed by the anion. Anion must end with the word IDE or "ide". Drop the last few letters and adding IDE, and we have to write the numeral Roman. Must be used in case of more than one oxidation state for the element or the metals. It belongs to the transition metal azoles, and its properties: high melting point, high boiling point, hard and brittle or easy to broken, good insulators, or form crystal, and also form crystal, good electric conductivity and conduct, or we say excellent conductor when they are dissolving in water. Ionic compound have high enthalpies of fusion as they are release energy due to formation of bond. Okay, this is the last of our today. We can summarize all the points that we are going to take or that we have studied today, all the items that belongs to the ionic bond. Okay, this is the end of our session today. I hope you enjoy. Okay, anyone have a question, please send it below the video. I hope you enjoy all the points today, and I think we must concentrate this term on chemistry as you are in scientific section. Okay, I hope you good luck and goodbye.